Welcome to Brewfix, where coffee meets craftsmanship. If water chemistry still feels confusing, don't panic. You don't need a chemistry degree to understand why water ruins espresso machines, destroys flavor, or causes endless scale problems. As a coffee technician, I can tell you that water chemistry is one of the most misunderstood and most expensive mistakes in coffee. In this video, I'll give you a quick, practical chemistry lesson so you understand water hardness, pH, and why they matter for espresso machines and coffee taste. What water hardness really is. Water hardness is not one thing. It's the combination of temporary hardness and permanent hardness. Temporary hardness, also called KH, comes from bicarbonates of calcium and magnesium dissolved in water. When water is heated, these bicarbonates break down and precipitate out as carbonates, forming white limescale. That white residue you see on kettles or pans after boiling water is the same scale that forms inside espresso machine boilers, heat exchangers, and pipes. Temporary hardness is the primary cause of scale damage in coffee machines. Permanent hardness and why it's different. Permanent hardness behaves very differently. It comes from sulfates of calcium and magnesium, commonly gypsum. Unlike temporary hardness, these minerals do not precipitate when water is boiled. They stay dissolved and pass through the machine without forming scale. From a mechanical standpoint, this is good news. Gypsum doesn't clog boilers. However, it still affects taste, often adding a mineral or chalky character to the water and the coffee. So while permanent hardness doesn't destroy machines, it absolutely shapes flavor. Total hardness, GH, explained simply. Total hardness, often labeled GH, is the sum of temporary hardness, KH, and permanent hardness. Total hardness égale temporary hardness plus permanent hardness. This value is usually reported by water companies and expressed in German degrees, degree DH. The problem is that GH alone doesn't tell you how dangerous your water is for espresso machines. Two waters with the same GH can behave very differently depending on how much of that hardness turns into scale when heated. Why espresso machines care about this? Espresso machines heat water constantly under pressure. If temporary hardness is too high, scale forms rapidly, insulating heating elements, blocking valves, and stressing pumps. Permanent hardness won't clog machines, but it can flatten flavor or make espresso taste harsh. The goal isn't zero minerals. It's balanced water that protects the machine and extracts coffee properly. Understanding pH without overthinking it. pH measures how acidic or alkaline water is on a scale from 1 to 14. pH below 7 means acidic. pH above 7 means alkaline. pH of 7 is neutral. Mineral content affects pH. Softer water tends to be more acidic, while mineral-rich water is more alkaline. From a technician's perspective, pH is critical because acidic water corrodes machines. To protect espresso machines, pH should never drop below 6.5. Machines exposed to acidic water often suffer internal corrosion long before users notice any obvious symptoms. Every espresso machine tells the story of the water that flows through it. Scale, corrosion, failing valves, or perfectly clean internals. None of it is random. Once you understand water hardness and pH, you stop reacting to breakdowns and start preventing them. At Brewfix, I break down the technical side of coffee so machines last longer, espresso tastes better, and problems finally make sense.